Hey guys, so today I'm going to be talking about one of the talks that I really enjoyed out of the physics lectures that I presented this semester. The one I enjoyed the most was the piano talk that was done by Nicholas Giordano, and one of the reasons why I really enjoyed it was because I've been playing the piano for a really long time. So it's really cool to see how something I'm learning at school and in class can be applied to something I enjoy doing out of class. And it's also interesting to see how physics plays a main role in the creation of piano and how the piano works. So I'm kind of just going to talk about some of the things I learned from the lecture, and one of the key things I learned was the importance of hammers in a piano. When I played on a baby grand, you can see the hammers hit the actual strings of the piano, and I never really thought about how that has a huge effect on the sound that it's emitted. And so I learned that hammers in the past were made out of an outer layer of leather and an inner layer of felt. And when the note is played softly, the compression is small. It's usually about a few tenths of a millimeter. And when the note is played loudly, there's more compression. But the inner layer is a lot stiffer, and so that helps the hammer make an effectively louder sound when you hit the key. Another thing we know is that when there's a collision between softer objects, the sound is different when there's a collision between two really hard objects. And the collision time is shorter for harder objects collisions and then longer for softer object collisions. And this kind of ideas can be applied when you're looking at a hammer and a string in piano. Another thing I learned was this picture was shown in the lecture, and as you can see in figure 8, when the hammer hits the string, the collision generates wave pulses that are directed in opposite directions. So you see the wave pulses that are directed in two opposite directions. And then in figure B, you see that the hammer is usually still in contact with the string when this second wave pulse bounces back. And when it bounces back, it actually inverts the wave. And because it inverts it, when it hits the hammer, it actually puts a large downward force on the hammer. Another principle of physics that was mentioned in the lecture was Hooke's law, which I thought was familiar because you learn about it in Physics 1. And Hooke's law states that in springs, the force exerted by the spring is proportional to compression. However, in piano hammers, this is not the case because piano hammers is an example of a nonlinear spring. So I found this lecture to be really interesting, so I decided to check out the book by Giordano. And another main concept that he talks about is tone decay, which was really interesting to me because, as you know, in the piano, different notes last longer and you can hear them longer, and you also have the pedals on the piano that can influence this tone decay. So as most people know, when you're listening to music, the bass notes usually decay much slower than the treble notes. And this occurs because when you hit the keys, the kinetic energy is transferred from the hammer to the string, which is in turn transfers energy to the soundboard. And the tone decays with the time. That is a portion of the energy that is radiated from the sound, and the rest of the energy is lost in frictional effects within the soundboard, which makes sense because when you're listening to music, the energy is lost as you hear it because the sound is being emitted. Two quantities that have really important effects on the tone decay is the mechanical impedance of the soundboard and the string tension that's within the piano. Mechanical impedance kind of tells you how quickly the energy can be transferred to the soundboard. And in addition, there's also a trade-off between tonal volume and decay time. So if you have a small impedance, it gives a loud tone that decays quickly. So hopefully you found my video somewhat interesting and that you found this lecture really interesting as well as I did. Thanks for watching.